up, guys? So here I'm in the garage, and I'm trying to clean up and make some more space available. So I have my rack here. That's my steel rack, and I made this I don't know, a year and a half, 2 years ago, whatever. And it doesn't take up too much space, but I'm still trying to just to maximize my floor space. So I'm thinking of just going with I guess like a skinnier rack and going vertical. So I have some scrap tubing. I literally got this for free. This is a 2.5 inch schedule 10 pipe. Just like I said, got it for free. It's just sitting on the rack anyways. So it's about 2 feet wide, give or take. So it's taking up 2 feet from the wall. So I was thinking, you know what, maybe I can just go vertical and just go like pretty much just kind of like that, the width from the edge of the garage door to the walls, which is about, I don't know, about 12-13 inches or so. And that way I can just keep a small footprint and then just go vertical. So let me see what I can come up with this scrap, and let's see what I can do to save some space. All right, guys. So here's what I ended up doing. Ended up updating my BendTech software. I had a BendTech 6X Pro. I updated to 7X. So I went ahead and I did that, and I came up with this design for the steel rack. It's a pretty nifty, tube bending software. Even though I'm not actually bending any tubes, you can work with the designs, even if you're not actually doing any bends. So here's the design I came up with. It's about 5 feet wide, about 6 feet tall, and I have a bunch of smaller racks. That way, so I can save on floor space. It's only about just shy of 15 inches from the back part all the way to the front. So it's gonna save me some space there. So this is what I came up with, and those little red tabs it's just a plate just to kind of hold everything in place. The bottom leg is flat, and the rest are angled upwards about 7.5 degrees. And each one just keeps getting progressively shorter as they get higher and higher along the vertical tube there, just to kind of keep the center of mass a little bit more towards the back side. It's going to be secured anyways to the concrete floor, but still, so that way I can just kind of save space and just hopefully keep everything a little bit more organized. So I already did this design, as you can see. The nifty thing is that you can use pretty much whatever material you want. You can specify your own material, your diameters, your wall thicknesses. You can work with just regular round tubing, square tubing, rectangular with unequal dimensions. I think you can. That may be an option. I don't remember. I would have to check. But yeah, it works pretty good. It keeps track of all the parts that you're using. You name them and everything, and you can see individual parts there. And no, it's already there. So let's see, details. Keeps track of how much material you need. So 526 inches is what I would need for the pipe. So that ends up being about how much? Let's see. Yeah, it was about 46 feet. So I think it's doable. With that scrap pipe that I have left over. Again, it's just sitting there. So that's about 155 pounds plus another 7 pounds or so for the 3/16 plate, for those little supports right there to keep everything in place. So overall, it's going to be about 161 pounds. So that's based on the information that I input. For the tubes, you tell it how much each linear inch weighs, and for the steel plate as well, you input how much each unit weighs, and it calculates everything for you based on either the volume or the area and the thickness. Okay, so let's look at the cutting. So here I have already generated the cut wrappers for the fish mouth copes. As you can see, the first one is this little forward foot, this green one. This is the one that's going to be cut to these red tubes over here. So basically my plan is to, I'm gonna first create, you know, this square, or I guess I should say rectangular frame with the diagonal. So I'm gonna create that first. So it's already gonna be, I guess, pre-existing. So that's why this one is gonna match up to that triple joint right there. We change the projection, or the display I should say. So there you can see it generates the proper fish mouth cope to mate up to all of those tubes right there. So that's only one end, so that's only one cut wrapper. But depending on the part, for example, this top horizontal tube, it's gonna have two identical copes, one on each side. So it's gonna go on there before the diagonal goes on there. So they'll be identical, but instead of using only one cut wrapper, I generated two for the upper horizontal. So I generated this one here, as you can see, standard fish mouth cope, and the one on the other side as well, same thing. So the reason I generated two is because here you can designate the start and the end. So when you look at one, it has some guides see lined up with the second cut mark. This is the first wrapper. You wrap it on one end, and then this blue line, you line it up all the way on the other side. In other words, to maintain the proper orientation of the cuts. Then it has these red lines to help guide on the distances. So you can use the red line to match up to either the end of the tube, if there is not going to be, you know, any other cope on the other side, you can just match it up to the end, or you can match it up this line 52¼ inches to the second cut wrapper. It's going to be on the other side of the tube. It'll have its own red line. Close this, so the end part, details, here we go. See that? 52¼ to the first cut wrapper on the other side. And then you line up the blue mark with the blue mark, and that way it maintains the proper orientation of the copes, because you don't want it to twist it, then it's not going to match up on one side. So pretty cool. The diagonal, same thing, similar thing. Zoom out. The diagonal will have, again, two cut wrappers, same cuts, but you have the two wrappers in order to generate the cut marks that are going to be lined up. So again, it helps you maintain the proper orientation. You just have to have a line going down the tube all the way down, you know, without having it, you know, twist or turn. It's got to go straight down on one side. So you could use, if you have a piece of angle iron that's long enough, you can use that to make this line, or you can come up with some other way with like some stringers or whatnot. So yeah, these cutting profiles that are generated are pretty cool, and as you can see, it takes into account the wall thickness. There we go. So pretty cool. Takes everything into account, and of course, gonna use the plasma cutter for this. You know, not gonna try and find or make a hole saw, you know, for this size pipe. So I'm just gonna use the plasma cutter, and then you know, just trim it down or whatnot with a grinder if need be to smooth it out. So yeah, so there you have it. This is what I plan to make, and of course you can print everything out. In this case, I had to change the margins on the 8.5 by 11 sheet of paper, because, you know, with this size pipe, the cut wrapper ends up being pretty long, you know, because it's almost 3 inches in diameter. Multiply that by pi, that's over 11 inches, so that's why, I'm sorry, not over 11 inches, but it's close enough that it hits the margins if you leave them at 1 inch. So I just expanded them a little bit, and then it fits right on the piece of paper. You can either print a PDF or to save them, and then print them later, or you can just print them straight up. You can print each one individually, or here in the setup pack, you can just print everything: the image, bending instructions. In this case, there's no bends, obviously. The tube lengths, which is important, and then the cut wrappers as well. So again, you can print the whole thing to PDF. You'll have to rename each one. Every single one of these will be like a separate page or pages. So you would have to just rename it, or you can just print it straight up. Either way, and it looks something like this. Here we go. So it gives you the image, however you had it last on the screen. All the legs, and this is the cut wrapper. The description is underneath the cut wrapper itself. As you can see, they're pretty long in this case because the tube itself is I guess pretty large diameter. I mean, usually for motorsports, they're working with smaller diameter tubes or whatnot. So pretty cool. So now you just print it out, cut them out, and make your marks, and then just clean up the ends if you cut up with a plasma cutter. So yeah, so let me work on that. Let's see how this thing turns out.